Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Physics SSC 2 National Book Foundation Physics SSC 2 Unit number 10 Simple Harmonic Motion and Waves. Today we will solve SLO base according to FBISC requirement numerical problems question number 1 to 4 in first part. Remaining numerical we can solve in a second part. So first of all numerical problems question number 1. A simple pendulum has time period 2 seconds. It's called a second pendulum. Find the length of second pendulum on Earth and on Moon. So, first of all, what do you know about second pendulum? If the time period of simple pendulum that is called first time pendulum. Now here time period is 2 seconds. 2 seconds mean the second pendulum. So we can calculate the length of pendulum on earth and also on moon. First of all, write the given data. Time period of simple pendulum T is equal to 2 seconds and G on earth, the value of gravitational acceleration on earth is equal to 10 meter per second square and the value of G on moon, the gravitational acceleration, the value of G on moon is equal to 1.62 meter per second square. Now required that length of pendulum on earth LE and length of pendulum on moon LM. So the formula time period on earth T is equal to 2 pi L over GE. GE gravitational acceleration on earth. Similarly, the time period on moon Tm is equal to 2 pi L over Gm. Gm means gravitational acceleration on the surface of moon. Now we can calculate the value of length. Then solution, we know that time period T is equal to 2 pi L over G square root. Taking the square on both sides, then T square is equal to 4 pi square L over G. Now we can find the length, then G is multiply on other side and 4 pi is divide on other side. This implies that L is equal to T square G upon 4 pi square. In first part, on the earth, length on the earth is equal to T square GE divided by 4 pi square. Putting the value, then length of simple pendulum on earth is equal to time period 2 square multiplied by 10 upon 4 into 3.14 whole square. Here 2 square is 4 and 4 cancel out by 4. So remaining answer 10 divided by 3.14 square. 3.14 square is equal to 9.8596. Now 10 divided by 9.8596 is equal to 1.02 meter. Similarly, we can find the length on moon is equal to T square GME over 4 pi square. Putting the values, then length on moon is equal to T square GME divided by 4 pi square. Value of T is 2, 2 square multiplied by 1.67 divided by 4 into 3.14 square. 4 cancel out by 4, then 1.67 divided by 9.8596, that is equal to 0.16 meter. Now, result is that length of pendulum on earth LE is equal to 1.02 meter and length of pendulum on moon LM is equal to 0.17 meter. In question number 2, given statement is that a pendulum has a time period 5 seconds. What will be the length of pendulum on moon to have the same time period? Gravitational acceleration on moon is 1 upon 6 of gravitational acceleration on earth. Now we can write the given data. Time period of simple pendulum T is equal to 5 seconds and gravity on earth is equal to 10 meter per second square and value of G on moon is equal to Gm is equal to 1.62 meter per second square. Now we can calculate required that length on moon, but we can calculate both on earth and on moon. So we consider the element length of pendulum on earth LE is equal to question mark and length of pendulum on moon LM is equal to question mark. Then we have the formula T is equal to 2 pi L over G whole square root and time period Tm is equal to 2 pi L over Gm whole square root. Then so in question only requirement is that time period on moon, but we can find on earth and also on moon. So we have solution. We know that T is equal to 2 pi L over G square root. Taking square on both sides, so T square is equal to 4 pi square L over G. This implies that L is equal to T square G over 4 pi square. First, we can find the value of length on earth. LE is equal to T square GE over 4 pi. Putting the values LE is equal to 5 square multiplied by 10 divided by 4 into 3.14 whole square. 5 square is 25. 25 multiplied by 10 is equal to 250. Taking the square of 3.14. The square of 3.14 is 9.8596. Multiply by 4 is equal to 39.4384. Now divided 250 by 39.4384 is equal to 6.34. Now calculate the length on moon, that is also required in question T square GME over 4 pi square. Putting the values, then length of simple pendulum LM is equal to T square GME over 4 pi square is equal to 5 square multiplied by 1.67 divided by 4 into 3.14 square. That is equal to 41.67 divided by 39.4384. So divided the 41.67 divided by 39.4384 is equal to 1.056. So the result is that length of pendulum on earth is equal to 6.34 and length of pendulum on moon is equal to 1.06 meter. Similarly, in question number 3, a pendulum of length is 2 meter vibrating at a planet. It is complete one revolution in 5 seconds. What is the value of G gravitational acceleration on this planet? So first of all, write the given data. Length of pendulum is equal to L is equal to 2 meter and time period T is equal to 5 seconds. Now required that value of G on planet. So we have write the formula time period at planet is equal to 2 pi into L over Gp square root. Gp means gravitational acceleration on planet P. So we have Tp is equal to 2 pi L over G square root, putting the values 5 is equal to 2 pi into 2 over G whole square root. Taking square on both sides, 5 square is equal to 4 pi square multiplied by 2 divided by G. Then G is equal to 39.4384 multiplied by 2 divided by 25. That is equal to 78.8786 divided by 25. That is equal to 3.155. So the value of G on planet Gp is equal to 3.16 meter per second square. So the result is that the value of G at moon or planet is equal to 3.16 meter per second square. Similarly, in last question, what is the time period of mass spring system if the mass is attached to the spring is 500 grams and its spring constant is 220 Newton per meter. So, first of all, write the given data. Mass m is equal to 500 gram is equal to 0.5 kg and spring constant K is equal to 20 Newton per meter. We can find that the time period. So write the formula T is equal to 2 pi m over K whole square root. Because in a mass spring system, the time period T is equal to 2 pi m over K square root. Now, for the solution, putting the values. T is equal to 2 into 3.14 into 0.5 divided by 20 whole square root. So, T is equal to 2 multiplied by 3.14, 6.28 multiplied by 0.025 square root. Taking the square root of 0.025 multiplied by 6.28, that is equal to T is equal to 0.99 is equal to 1 second. So the result is that time period T is equal to 0.99 second or 1 second. In next video with remaining numerical, best of